Hello there, YouTubers, and welcome to another episode of DrCassette's workshop. Today, we're going to give this project a bit of a restart. This is the JLH Class A amplifier. It's using a pair of 2N3055 transistors in each channel, plus this little driver board right there. As you can see, everything has pretty much successfully been built, and it is all pretty much ready to go, with the exception that it's not a proper amplifier yet. You can probably tell it's not wired up yet. And this is the classic problem in DrCassette's workshop. Projects are, well, they are exciting for a rather limited amount of time, and especially when it comes to this kind of final assembly, it's just... nah, it's boring. I don't like it, and so very often it just doesn't happen. I have several boxes full of stuff, full of little circuit boards and various different projects that just never made it to a final product that you can actually use in your everyday life. Well, with this, it has been looking like it was going to be the same. Problem is, I recently moved and I'm now having to pay for my power bill myself. So having a big power-hungry Class A amplifier in your living room for a daily use type of application, it's just not very attractive. So for a while I thought I was just gonna, well, put this into another shoebox and forget about it, just like I did with all those other projects, with all those other items. Well, some of you guys have requested that I continue with this, and you've been asking, well, what's happening with this? Is there any progress? So I said, okay, it might be a waste of time because I may never be using this, but let's just finish this just so that I finally have another project that I actually finished, because that hasn't happened in years. You know, repairs are nice because the exciting part is repair, and once you're done with that, you're done. Building projects from scratch, you know, getting the parts can be a bit of a pain. Assembling everything, getting it to work, that is the exciting part. Fault finding and all that can, well, it can be exciting, but it can also be rather frustrating. And then, as I already said, doing the final touches, you know, turning a circuit board into a usable product, that's usually just very, very boring. So that's the explanation to kind of kick off this video. Now let's go ahead and start with the actual project. Now, what I've been doing so far is I've been putting all the components into this case right here that I once found at the dump, and it all has been working out quite nicely, except for one big problem. I guess you can already tell that is not at all going to be enough for a Class A amplifier, because the heat sinks are getting extremely hot. And of course, they are not only getting hot under load, no, they are getting hot all the time. So, you know, this has been an issue, and I've put in this ventilator fan because I thought, well, you know, that's going to fix it. But really, in a piece of audio equipment, a ventilator fan really is just yet another problem. So, you know, putting the amplifier into this housing, it's just not going to be going anywhere. It's just not going to work out. So, well, what I have right here, this is a recent dump find. This is a, well, what is this? A Technics SU610. It is an integrated amplifier, as you can no doubt see, and it is a rather cheap and flimsy one. I guess you can also see that. I mean, we just take a look around. The transformer, well, I've seen cassette decks having a bigger transformer than this. This thing is kind of ridiculous. Then, of course, we got, high-tech, new Class A. Well, what it really is a so-called BC power module sitting right there, looking rather ridiculous. The great thing about this is we have a lot of the amplifier infrastructure already in place. We got our speaker jacks, and these are actually the nice ones, the nice screw terminals instead of these weird twist and lock that Technics had for a long time and that love to break. We got our power input, we got our RCA jacks already in some nice cutouts in the back. We got input selector, we got the volume control. It's all there. So what I'm going to do now is I'm going to rip this all out of here, and then we're going to put the JLH Class A amplifier from this case over into this one. Because if we just look at the top cover to this case right here, I guess you can all agree we're not going to have any temperature related problems with this, even without using a fan. And here we have the Technics amplifier with all the unimportant bits removed. So you can see I still have the mains input right there. It's a jack, nice and convenient, just a figure-of-8 thing. We do also have a choke on there, which might be kind of nice. And we have the speaker terminals upside down. It's going to be easier to hook them up this way. And there are the inputs. I got one of the input blocks mounted, but I of course kept all of those. And up front, nothing left in there either. We do have the power switch right there. That just simply screws back on like that. And we got volume control and the input selector. Those two items will remain as well. And also took apart what I had done so far. Took all the components back out of the housing, and I tell you, this is going to fit much nicer in here because it's bigger. So it's going to be easier working in this. As you can see, I have the outlines of things drawn and where I need to drill the holes and how big the holes have to be. That's all there. So I'll now take this all apart again, take the front off, take the back off. That can all be done with no problem, thankfully. And then I'm going to take this to the bottom part, to the drill press, and get all the holes done. Now, as for the power supply, I don't have a circuit board for that yet. The power supply is going to be located right there. But right now I don't know if I'm going to do it on a circuit board or if I'm just going to do point-to-point wiring. If I do it on the circuit board, well, there are plenty of holes already there, so I guess that's going to be fine. And we're getting closer to the point at which we were when this was all still in the old case. I got the transformer and the two heat sinks with transistors mounted, and as you can see, cut some big slots, some big holes into the bottom there and over there to allow some really good ventilation going through those heat sinks. So let's hope that's going to work out. And several hours have gone by. I wired up this channel, the amplifier, pretty much. As you can see, those ridiculously long wires are pretty much all gone. Have been trimmed down to a proper length, so that we shouldn't have any more problems with that. This one's not hooked up yet because I will have to come up with a some sort of a provision that allows me to measure the collector current flowing through the transistors. One very annoying thing, and that's where Murphy's Law is coming in, I guess. The transistors were all in the wrong position. So, the way I had this set up initially, I would have had this transistor here going over there and that transistor going over there. So I would have had the wires crossed, and I guess that that would have caused me some trouble. So also over here I'll have to do exactly the same. The transistors are in the wrong positions. so I'll have to swap them. Have circuit boards nicely mounted, screwed in place. There is a transformer. We've got some standoffs from the original circuit board of this amplifier. And here, you could already see it, is the power supply unit. And yes, as you can see, I finally decided to go with a circuit board. Consequence of that is, obviously, it takes up a bit more space, so I wasn't able to fit in these big capacitors here that I had lying around. So I only got these 10,000 microfarad capacitors in here. I hope that's going to be enough. On the bottom, yep, that looks kind of ridiculous. The idea behind this is I want to have a very thick conductor so that you know, a spike in current draw can actually be taken out of the power supply. What I've done in order to do this, I kind of left this wire here to show it. I put in a wire into here, and then I just went over that with lots and lots and lots of solder. And you know, this wire I'll have to trim off, of course, and then that'll be all good to go. Rectifier bridge. Yeah, I did some manufacturing there. Oh, look at that. Isn't that neat? Well, little heatsink from some random IC, and then I got a bit of a sandwich design going on. Got the rectifier bridge down in there, and then this plate up front to hold it in place, because the bridge itself does not have any mounting holes. I really hope this thing still works, because this is, I don't know what on earth, but this is a mistake that I always make when working with rectifier bridges, soldering them in place, hooking them up. I always kind of overheat them, and this thing did get extremely hot, and I guess without the heat sinks in place it certainly would be dead, but this way, knock on wood, I hope it still works. In addition to the 10,000 microfarad capacitors for low frequency noise on the rails, or against that noise much rather, in addition to those, I'm going to put in some 22 microfarad and some 100 nanofarad capacitors across each one of the rails, and that's going to be against higher frequencies, because you know, the thing is, in theory, of course, these big 10,000 microfarads capacitors would also suppress any high frequency noise. In reality, they really don't care. So you have to have smaller capacitors in place in addition to these large ones, and since I had them all lying around, I decided to go with 2 additional ones per rail. However, before I solder those in, I'm just going to go ahead and test this thing, hook it up to the transformer and turn it on, and hopefully it's going to work. Check this all on the oscilloscope, and I got my little got these little terminal thingies put in, and as you can see, I also got plenty of those hooked up in parallel. Obviously this end is where the transformer is going to be hooked up, and on this end we're going to have minus 20 volts, plus 20 volts, and then this big terminal in the middle, in the center, is going to be the star point for the ground. So all the ground connections are going to end there. I finished the power supply, and as you can see, I got it hooked up temporarily to the transformer and to the scope. One word of advice: these two are connected together internally in the scope, so you may be tempted to swap the polarity around on the negative supply rail to get correct polarity on the scope, but if you do that, you're going to be getting a short. So yeah, that being said, let's take a look at what the scope says. There it is, and as you can see, I got it on a 400 nanosecond time base. Sensitivity is all the way up at 2 millivolts. I have it AC coupled, so we're not getting any DC. Make things a bit easier. And, well, there it is. And as you can see, we are getting a fair bit of noise. However, that's not the fault of the power supply because that is turned off. Ain't got any power going into there. However, we can make that happen. Let me go ahead and turn on the power, and we're going to watch the scope, and we're going to watch the differences between no power and power. So we turn this on right now. As you can see, we are getting a bit of a power on process, bit of an overswing, and let's go ahead and turn this. Let me see what I can do here. Turn the time base. Okay. Okay, so as you can see, we are now getting what looks to be a little bit like a ripple. It's kind of going up and down, like so. Now let me go ahead and hook up a load resistor so we can see if we end up with some some more ripple. Things are starting to look increasingly messy. I now have the 33 ohm load resistor permanently attached. That is causing a current flow of about 550 milliamps. And as we look at the scope, things are not looking quite as ideal as they just did. We're getting quite a bit of ripple. Frequency is 100 Hertz, which means that the rectifier bridge is in fact working right, because what that does is it basically doubles the frequency, the mains frequency, and we are getting perfect trigger because I am triggering at the mains, as you can see down there, AC 50. So that is that. Unfortunately, we are getting a, according to the measuring menu, we are getting 520 millivolts peak to peak on this, which really isn't good. Because the thing is, if I adjust the collector current for these amplifiers to 1 amp, we're going to have a constant current draw of 2 amps coming out of the power supply. So if this already has such a lot of ripple at half an amp, you know, at 2 amps, this is probably going to become a bit of a problem. Now, the more the better, they say. So I have, in addition to this 10,000 microfarad capacitor there, we're of course only looking at one of the 2 rails. I have this 1200 microfarad capacitor, or not 1200, 12,000 that is. So we hook that up in addition to the other one. We have 2 interesting things happening. First of all, less ripple, so that is definitely good. We're now having, 288 millivolts peak to peak, so cut that down in half. We're also getting some action on the other rail, which is kind of interesting. It seems to be some sort of interference going on with my alligator clip leads, because if I disconnect the negative lead going to the capacitor, it goes away. So that's kind of weird. And adding another 12,000 microfarad capacitor brings our peak-to-peak ripple voltage down to around about 200 millivolts. So yeah, we are making progress. The more filter capacitance you add, the less ripple you get, of course. That's what I expected. But of course, this also means that this power supply, I'm going to keep it in there because for right now it works, and for testing the amplifier it's definitely going to be enough. However, if I really want to turn this into a daily use kind of device, that really shouldn't have any background noise at all, I'll definitely have to invest into some much bigger filter capacitors. And of course, investing in those also means that I'll have to invest into a bigger rectifier bridge, because that little thing that I got going on right there is definitely not going to be able to handle the turn-on current of those huge capacitors. Of course, also space is probably going to become a bit of an issue in this case. Oh well, so that's still going to be a bit of work, I guess. Since I can use it in other applications too, I decided to finish this not so perfect temporary power supply anyways, finish it properly. So you can see now I don't only have the rectifier bridge with heatsink and the two 10,000 microfarad capacitors, I now also have the little capacitors down in there that we've discussed a couple of minutes ago, and I also put in some bleed resistors. These are like, I think this is 150 kilo ohms, but really they measure to be like 110 kilo ohms. But anyway, so those are going to cause a slow decrease in charge, these capacitors, because I hate getting unexpected sparks out of things like this. So that's that. Of course, one disadvantage of making these solder traces is as the solder cools down, of course it shrinks slightly, and it well, this ended up pulling the circuit board into kind of a weird shape. That's definitely not straight anymore, and I guess you can all see. So anyways, let me go ahead and put this in. And some more progress has been made. I put the temporary power supply in place, hooked it up to the transformer right there. It's also hooked up to the amplifier, to this channel right here. This channel so far only has a ground connection, because I first want to power up this, make sure that it's all working, and then I want to go ahead, hook this one up, and test that one. So that's the plan for that. I swapped the transistors on this heatsink as well, because I had to do that in order to avoid any wires crossing each other. That was a bit of a job, because one of the transistors kept shorting out against the heatsink, so that was annoying. I mean, these stupid insulation materials really aren't very good. Hate that stuff. Oh, anyway, so that finally has been done, and all the transistors have been hooked up to their driver boards. Nice and neat. Wires being as short as possible, trying to avoid crossing wires and all that. I also put in these resistors. These are some high power resistors that are really just there as shunt resistors to measure the current, the collector current going through the transistors. Of course, I'm intending to run this on 1 amp of collector current, so it's going to be quite an easy solution. Just hook up a voltmeter across that resistor, and when the value displayed on the voltmeter equals the value of the resistor, then it's set correctly using these two potentiometers. So that's where we are right now, and this is also the end of the winter holidays that I'm spending at my parents' house, so we will continue this project, but progress will go on slower from this point on, because I don't know when I'll be able to get back into the workshop for enough time to really mess around with this thing. Thank you for watching, and see you again soon.